We will now solve EEE51 homework 1 problem 2. With this circuit, we can get the value of VDD is equals to 10 volts, Vout is equals to 3 volts, R3 is equals to 1000 ohms, R2 is unknown, R1 is 2400 ohms, V1 is 5 volts. With the MOSFET values of the absolute value of VTH is equals to 3 volts and V and K is equals to 1000 microamps over voltage squared, and lambda is equals to 0. So since we want to get the region of operation of M1 and the value of R2 to satisfy this whole setup, we must first get a KCL equation on node V out in order to get the current in M1, which in turn we can get the value of R2 since it's biasing the M1. So making the KCL equation at V out, we can get the equation IDM2, which is the current in M2, is equal to V out over R3, which is the current in R3, and IDM1, which is the current in M1. Then rearranging, since we want the M1, IDM1 is equals to IDM2 minus V out over R3, which is our first equation. Now, since we have the value for V out and R3, we have 3 volts over 1000 ohms, getting us an IR3 of 3 milliamps. Since now we want to get the drain current in M2, we must first find the region of operation of M2, which is, we can check by looking at the VSG, since it's a PMOS, and the VSD. So the VSG is just the difference between the source voltage and the gate voltage, and we can see that M2, the source is connected to VDD, which is 10. The gate is connected to V1, which is 5. So we have a value of VSG is equals to 5 volts. Now we will check for the VSD. We have the source voltage again, which is equal to 10 volts, and the drain voltage, which is equal to 3 volts. So we have the VSD is equals to 7 volts. Now we have to check for the region of operation, since we know that for it to be in saturation, we will check VSD should be greater than or equal to VSG minus VTH for PMOS, and VSG must be greater than or equal to VTH. And since 7 volts is greater than or equal to 5 minus 3, so which is true, and 5 is greater than 3, which is true. So we can say that the M2 is in saturation. With this, we can just get the current passing to the M2 given the saturation drain current equation. IDM2 is equals to K VSG minus VTH squared 1 plus lambda VDS. And since we know the value of lambda is equals to 0, this will be just 1. So we are left with K VSG minus VTH equals to 1000 microamps per per voltage squared multiply by VSG of 5 minus VTH of 3 squared, which is equals to 1000 times 4, which is equals to 4000 microamps, or which is equal to 4 milliamps. Going back to the previous equation, since we know IDM2 and V out over R3, which is 3 milliamps and 4 milliamps, we can get the value of IDM1, which is equals to IDM1 is equals to 4 milliamps minus 3 milliamps equal to 1 milliamp. But now we will have to assume the region of operation of M1 since it is unknown, and we have the current passing through. We will just first assume it is saturation, then we will just have to check later if the result of assuming that it is really in saturation will make it in saturation. So given that, we will write the equation for the drain current in saturation. ID M1 is equals to K VGS minus VTH, since this is an NMOS squared, 1 plus lambda VDS. Again, this is 0, then this would just be 1. The VGS of the MOSFET is unknown since we don't know the value of R3, and the source is connected to the ground, and VTH is equals to 3. So this is 1000 microamps per voltage squared. Then we will have 1000 microamps is equals to 1 milliamp. VGS minus 3 squared. This is 1000 microamps is equal to 1 milliamp, so this will be 1. So give me 1 is equals to VGS minus 3 squared. Square root of 1 is equals to VGS minus 3. Then go plus minus 1 is equals to VGS minus 3. So we will get VGS equals to 2 volts and 4 volts. Now, since 2 volts is a extraneous solution, we will just eliminate that one, and we will have VGS equals to 4 volts. Now, since we know VGS is equals to 4 volts, and the source is connected to the ground, we know that this gate voltage is equals to 4 volts. And now we can check for the region of operation. We can confirm the region of operation of M1. So we know that VGS is equals to 4 volts. The VDS is equals to, just since it's connected to V out, it's 3, and the source is 0 since it's ground. So we have VDS equals to 3 volts. Now we will check, is VDS greater than equal to VGS minus VTH? Greater than, so is 4 greater than, is 3 greater than 4 minus 3? Check. So, and is VGS greater than or equal to VTH? So it is 4 volts greater than or equal to 3. Yes. So that, then it means that M1 is in saturation, as we first assumed. So it is true. M1 is in saturation. Now we will just have to solve for the value of our 2 to make this setup, and it will be left to a simple voltage divider problem, since we know that we want the node connected to the gate of M1, which is this node, to be 4 volts, and this is connected to ground, and this is connected to VDD, which is 10 volts, and this is 2400 ohms. We will just have to make a simple voltage divider problem. So we want 4 volts is equals to 10 volts, the voltage division of R2, so R2 over R2 plus 2400 ohms. Then rearranging everything, we have 0.4 is equals to R2 over R2 plus 2400, or simply, so solving this formula, we will get R2 is equals to 1600